So let's get started. Hi everyone, my name is Flavio. I'm from Brazil, and I'll talk about your Django app as a user interface and how this affects the app development in Django. And I work at Vinta. I'm one of the partners of Vinta Software. We are an expert Django shop from Brazil. We work with React on front end mostly, and we work with companies from the US, mostly New York and San Francisco too. And we use a lot of Django in our backend. It's the main technology we use, and of course, all of our projects have multiple apps, multiple Django apps. And Django apps, if you look on the documentation, you see that the key idea behind them is reusability. And that's what the doc says, that reusability is the way of life in Python. You only need to write the parts that make your project unique. And this way, we need to think about Django apps as an API to reusable solutions. And thinking like that, we also came to see that an API is a user interface. And this is like a user interface that will connect a developer that's writing a new Django project with a reusable solution that you wrote or some other developer wrote. So we need to think that Django apps are APIs, and APIs are user interfaces. So we need to apply user interfaces knowledge to Django apps in order to make them really good, really usable. And by that, we bring the human factor into the Django app development. If you study usability, maybe you can summarize UI qualities into 4 values: simplicity, consistency, flexibility, and safety. Each of these values have inside them many heuristics, many qualities that you can apply, and we'll talk about them. First of all, simplicity. The Zen of Python already talks about simplicity. It says that simple is better than complex, as well as other stuff like beautiful is better than ugly, explicit is better than implicit, and all of the things involve around simplicity. And that's really nice, but how can we achieve that when developing Django apps? The first idea about simplicity is to focus on the 80% use cases. We must not try to focus on all use cases, otherwise we'll have a very complex API for our app. We need to focus on the top ones and think about the other 20% later. We'll see how. So for 80% of our app users, we want them to just use our app, just add it on the settings, provide some input for it, and then they should get the solution to what they are looking for. This is really good app usage because you just install it, configure it a bit, and you are done. But that doesn't mean we need to forget about the other 20%. Ideally, we want 15% to change some settings, inherit some classes, override some stuff, and then they will have the problem solved too. Even less than that, we want some of the developers to assume the flow, to use helpers, mixins, to combine with their own logic, to intertwine with their own logic, and then they'll have the problem solved. But there will always be 1% where we can never cover, and for those kind of users, unfortunately, they'll have to fork and make a pull request or something. And this means that for the 80%, we are talking about simplicity. And we will simplify these 80% use cases, while the other 20%, we are talking about flexibility. And we'll see how to work both on simplicity and flexibility. And a good idea to think well about the 80% use cases is to start with the README. Kenneth Wright, the author of Requests, which is an awesome Python library tells that, and we should follow this. This means that you should pitch to your users why this app exists, what it solves, to which extent. This way you define the problem you are trying to solve, and you start reasoning more about the scope of what you are building. And here are two examples. If you look Django.js Reverse, which is a good app, it only says that it's a JavaScript we are rendering for Django that doesn't hurt. And Django Impersonate, simple app to allow super users to impersonate non-super users' accounts. Those are two simple apps, but they are really good. They really solve what the problem that they are trying to solve. And if you are describing our app and you find yourself adding "and" on the description, maybe you should break into two apps. Shouldn't be a single app, should be two. For example, if you have a user app that says it's a Django app to handle user authentications and profiles, that's two concerns. Maybe it should have two apps, my auth app and my profiles app, instead of just a single one. And starting with the README, you can show how the developers can use your app. You can throw some sample code and most common use cases. And you should do that even before writing the real code. That's how Kenneth writes do, and maybe you should do too, because it allows you to have an overview of the problem you are solving, allows you to define a good API even before starting to write the code. And here is an example of Django filter that's also a Django app and does that very well. Also, to focus on the 80% use cases, you must know your users. You must know who are the people that you are helping. And to do that, you need to get people involved in the app design. You need to ask what they need, and you need to ask them to test the usage of your app. Just as a product that people are building all around Bay Area, your app is something that people want to use and people want to have a good experience with it, so you need to test it. And you need to measure also, because if you launched an app and maybe people are creating issues saying, hey, you should support this, you should support this, so maybe the 80% use case you thought about isn't complete yet. Many people are asking for more features, and you need to reason, hey, this is more than 80%, less than 80%, and you should adjust accordingly to support what people need. Another idea for simplicity is to reduce clutter for these 8% use cases. And a good heuristic about reducing clutter from user interface design is progressive disclosure. What's that? If you look at Google, you see progressive disclosure in practice. If you go to Google, even though Google is a huge company with many services, the main focus of Google homepage is search. If people go to google.com, they probably want to search. So if you go to google.com, it's very clear that search is there, and it's the first thing you want to do. It's the thing that 80% of the users want to do. That doesn't mean that you can't do other stuff. For example, you can get into Gmail, you can change your user profile, something. That other options are available there. But the main thing that search is the first thing you see. This is progressive disclosure. It's disclosure the most important things first, and the other ones are also available, but not as much focus as the main thing. And if you look into API design and Django apps, they have that too. From Django 1 search code, Postgres search code, you can just start simple. You can just use underline search and search for something in a field. But you can use more advanced search. You can use search vectors. You can use custom search queries with a custom language. And that means that the API is just one, but it's progressively disclosing the more complex approaches. And this is good. This is good API design. This helps with simplicity. Also, progressive disclosure means good defaults. You should make assumptions. We need to decide for the 80% of your users. Users like that someone decided for them already. Advanced users don't like that. Ideally, you want to decide for most of the users and require for them only the essentials. Only the essentials for the problem they try to solve. Only things that you can't infer from them. And there are many defaults to set. You must set settings, argument values, argument ordering, behaviors, environment. There are many things you need to consider when building an app and choosing good defaults for these things. For example, Django Debug Toolbar has very good defaults because to install it, it only works if the bug is true. So it's a safe default. It won't run into production and show your SQL queries to users. It has default panels, so if you install it, it just works with some basic panels. It uses jQuery from CDN, so you don't need to worry about static files. You just download from CDN. It doesn't show collapse by default. This is a small thing, but very important. It shows right there on your face when you install it, and many other things. But except for one thing, that little thing beat me a couple of times. I tried to install Debug Toolbar and wasn't able to because I forgot to set internal IP settings. And this setting is not always set into Django projects. It's not very common to set this. And Django Debug Toolbar needs this because Django own settings needs that to show debug info about templates. So Django Debug Toolbar also needs this. So this means that bad defaults propagate. If your API, if your app is used by another app and your app has a bad default, this bad default propagate to another one. So you have to be very careful with the defaults you are choosing. Also, to reduce clutter and have more simple apps, we need to avoid cumbersome inputs. Here is an example of a cumbersome input. If you create a mail message in Django and you add a subject and you add a to, this first code above is wrong because this first code will send an email to each letter of your to string, which is probably not what you want. The correct code is to add a list to the argument. And the argument name is very bad because it says to. It not say to list or recipient list. The argument name is bad and leads you to write wrong code. And Django fixed that by asserting that you are not passing a string. But that's not the best solution for that. The best solution is to raise a type error. It's an even better solution. In fact, I think the better solution at all would be to accept a single string. And in fact, SquarePy had the same bug, and they solved it like that. They accept a single string too. But Django opted to raise type error if you pass a to argument as a string instead of a list or a tuple. Reducing clutter too, we need to create abstractions for 80% of our use cases. And what are abstractions? This is something that we hear about a lot, but we don't think much about it. And maybe we can explain that with abstract art. Here is a painting with low abstraction value. You can see that this is a tree. Maybe you can see, I don't know. But the physical nature is apparent here. You can see that the painting is about a tree. If you move to more abstraction, the structure still suggests a tree, but it's less clear. It's getting farther away from the physical reality. On a high abstraction painting, there is a lot of structure, but the physical nature of the tree disappeared. And these three paintings belong to the same author, and the theme is the same. The theme is a tree. And only the hierarchy of the three qualities are apparent here, but the tree physical structure is not anymore. And surprisingly, all of these paintings belong to Mondrian, and eventually he evolved to full abstraction, which many of us can't understand, but maybe there is even a tree here, the tree nature of hierarchy. And to abstract in APIs, is to draw away from the physical, the how nature of something, to focus on the what nature. So good APIs, good apps, you use them by telling what you want and not how you want. And this is abstraction. This is good abstractions. In practice, here's an abstraction that I really like, which is Celery tasks. To create a task in Celery, you just add the decorator, and you are done. You don't need to worry about the inner workings of Celery, of registering brokers, registering the tasks, of managing how the arguments are passed to tasks. You don't need to worry about that. You tell what you want. You want a task, and then you have a task. Here's another example, Django Email. This is a good library that abstracts many email service providers into a single API. And it's a great Django app. I really recommend it. And you can, for example, set metadata, you can set tags, you can set the email to track clicks, and use this same API into multiple service providers. And you just say what you want. You want to track clicks. You don't say how, or you don't say which service provider works like this and other works a bit differently. One tracks clicks with images, other tracks in another way. You don't need to worry about it. You just say track clicks, and this is all abstracted. If you see any mail documentation, you see that it's really good because it tells you what you can use and which service providers support this, like Mailgun, Mandrill, Postmark, SendGrid, everything. And this is all abstracted for you. One problem with this is there is a thing called the law of leaky abstractions, is that all abstractions leak. Unfortunately, abstractions are not perfect. And this is a great article about from Joe Spolsky that tells us that. And if you look at Celery, I said that you don't need to worry about how tasks works, but unfortunately I lied. You have to worry about this because the workers can crash. The workers may face like memory leak or something, and they may crash. Your server may crash for some reason, and you lost tasks because of that. And this way you have to write tasks as idempotent tasks. That means that they can run again without introducing new side effects, and you have to use axlate on your tasks to solve that problem. So if a work crashes, you can start it again, and you can run tasks that were interrupted in the middle again. So this is all very complicated, but that's because it's a leaky abstraction. It's an abstraction that Celery couldn't take away from you. It's a thing that about how tasks works that Celery can't abstract from you. Is there any library, sorry? Take care of this? Probably not if they use brokers, task queues like Celery does, because this is something related to the environment. And if a worker crashes, you need to run the tasks that were interrupted in the middle again. And if you are running the tasks that were interrupted in the middle again, you have to make sure that, for example, you're not sending a duplicate email. And for that, to not send a duplicate mail, before sending the email, you have to check that you send it already. So you have to write this code. This is not abstracted for you. You have to write some code to prevent that. So you have to write your tasks as idempotent. There is no way to say, like, make this task idempotent. This will be like too much for a code to do. And all abstractions lie, but sometimes leaks are necessary. Sometimes complex is better than complicated. Sometimes we try to abstract too much, and this actually introduces more complex stuff, more complicated stuff than complexity. We have to embrace the complexity sometimes instead of creating complicated situations. A practical example of that is RPC versus REST. If you have like a RPC-like interface where you do like Facebook get profile from Guido and then set his name, these two lines here have a bug. Because if someone someone else tries to set the name for Guido concurrently from you, you have like, you override his changes. So these simple 2 lines have a problem because they try to consider a remote procedure call the same as a local procedure call. It doesn't have a lock or something like that. And this means that you shouldn't abstract network communication as local communication. You shouldn't do that. And REST doesn't do that. REST assumes that you are in a client-server model, and assuming that it gives you constraints, gives you things to prevent concurrent modifications, like if unmodified things. So this way you can modify Guido's profile only if it isn't unmodified since this date. And this is like optimistic locking, and it's a good solution for the problem of concurrent additions. And this means that REST accepts that it's into a more complex environment, that's the client server, instead of just considering the client server like the same of local development, local environment. So don't abstract what cannot be abstracted. We need to reason about the environment we are in before abstracting. Now talking about consistency, one idea for consistency that we can inherit from user interface design is recognition rather than recall. So for example, if you press F1 on Windows, you get help. That most apps on Windows respect that, and this is a thing that's consistent on Windows. It's recognition rather than recall. Or if you press F1 on Windows, you get that guy, which probably won't help you, but it's still consistent on the help thing. Or if you press F1 on Windows, you get like a security vulnerability, which is still consistent on Windows because Windows is full of vulnerabilities. And this is a real stuff. If you press F1 in a website in Windows XP, you get a 0-day vulnerability. But anyway, recognition rather than recall for Django means using Django idioms. And Django has many of idioms, many of abstractions that you can use, like query sets, models, middleware, managers. If you're writing your own app, you should use those things instead of creating new abstractions. Let's see some examples for template tags, query sets, and views. Template tags, very simple. You should provide template tags for presenting data. Like this library called Django Avatar. You can just show a user avatar, a user social avatar using the avatar URL or the avatar template tag. You should respect the configurability of class-based views. For example, Django Auttools has a password reset view that you can inherit and customize because it respects template name, form valid. It respects Django attributes and methods. So you can configure that really easy because those are abstractions, those are constructs that Django has and this library respects. And also, a thing that many libraries miss, many Django apps miss, but is very important, is custom query set methods for chaining filters. So for example, Wagtails uses this. You can search for live event pages that are under the events index by chaining different query set methods. Using live, descendant of, search. You can change the order of these. You can intertwine with your own logic there. And this is a good thing because Django already has this abstraction of query sets, and you can use it on your own apps to get chaining filters. And many libraries miss that. Many libraries just use managers instead of chaining filters for query sets, and this is something we need to care about. Also, for recognition rather than recall, we need to make declarative interfaces. Everybody loves Django admin because with just 2-3 lines of code, we can make an administrative interface. It's very declarative. We say what we want, and we get it right away. And many Django apps, good Django apps, have declarative interfaces too. Here we have Django import-export that you can declare some fields and be able to export them on admin. We have Haystack, where you can create a search index. We have Django REST framework, where you create an API declaratively. We have social auth, where you can define a pipeline to handle your social logins. And all of this happens declaratively with settings, with classes, with attribute settings. And this is very simple because it's declarative. You say what you want instead of how. So these are all great examples that are in the ecosystem, and we need to grab inspiration from those. Another thing about consistency is to keep similar things together and different things apart. So for example, Python does a lot of that. If you want to sort numbers, sort a list of numbers in place, you don't use sorted numbers, use a numbers.sort, because sorted numbers returns a new list. It's not in place. So these are two different ways to sort a list, one in place, other not, and they are different in form. So asymmetry of behavior should imply inasymmetry of form. This is a great article, The Little Manual of API Design. You should check it, talks about that. And it's really important to get the asymmetry of form if we have asymmetric behavior. So for example, should you use utils.py? No. If you have a Django app, don't put everything on utils.py. Use a utils module and add stuff there, like Django Haystack does. It has utils for geo, highlighting, loading, different modules in the same namespace, instead of just putting all together into a single namespace, because they are asymmetric in behaviors, so they should be asymmetric in form too. And related to that, we should be aware of false consistency. Sometimes we try to be so consistent that we glue together things that shouldn't be glued together. And here is a very opinionated thing, which is view sets. And I really disagree with Django REST Framework view sets, because if you look at the documentation, it refers to Ruby on Rails documentation, but we are not on Ruby on Rails, we are on Django. And it says that it allows you to combine the logic of related views into a single class. But why is this a good idea? I don't think it's a good idea, because the code looks good, looks simple. You can like have a user view set where you have a view for set password and another one for recent users. But maybe those things shouldn't be together, because you may have a bug here. You have a single query set where you are allowing access to all users, and maybe you will allow someone to set the password for another user. And the solution that Django REST Framework suggests for that is to add a permission classes on set password. So see that we had a thing that is general, and then it's not general again. So why making the first thing general? Maybe we should have two views instead of a view set. So we should be aware of false consistency. Sometimes we try to glue things together that shouldn't belong together. And you can always use mixins. You can always use helpers to share code between classes. Python and Django are very dynamic, and you can do that really easily. You don't need to have a single class for everything. Now about flexibility. Remember I said that we should make the 80% real simple, and we learn a lot of heuristics for that. But we should make the 20% possible. We must not forget the other 20% of our users. Users that would like to change settings, users that would like to assume the flow of our Django app, that kind of stuff. And to do that, we must increase the granularity of our app. That will help a lot with flexibility. And a really good concept related to that is the concept of integration discontinuity, introduced by this talk, Designing and Evaluating Reusable Components. And what that means? This means that your app, your API, has multiple options of integration. For example, for someone, they may be in an unsolved state, and they have 3 options to integrate with your Django app. One is solved, one just solves the problem, other is slightly overkill, and other is way overkill. Even though he or she will have to choose between 3 options, this is not bad, because the 3 options are there. A problem would be if there wasn't so many options. There were like just a way overkill option to integrate. Then you had a huge discontinuity between the unsolved state and the way overkill state. Let's see this in practice. Imagine you are building a web app for an online store, and they are asking for a feature to filter products by exact price. So here are this graph of options of integrations, and you can think about there are many options which add benefit to your project, but each of them have more integration work, more or less integration work. So this is into a single library, and you have many options on how to use that library, but they vary on benefit and integration to your project. So for example, you start here, and you want to add something. You start with the simplest integration work option, the option that will take less amount of work for you. So for example, you just use Django filter to allow filtering products by price. It's very easy. It's very few work, but not too much benefit for other use cases, only for this use case of exact price. Then someone comes and says, hey, we have a new requirement. It's not only filtering by exact price, but filtering by greater than or equal and less than or equal price. Then you have new requirements that prevent you from using the simpler option of integration. Now you have to move to another option of integration. And Django Filter supports that. Using the same class, you just add new fields, new options to filter on the price field, and you are done. Then another requirement comes. It has to filter products by price greater than equal, less than equal, but include approximate prices. You don't want to lose 1 cent difference, 2 cents difference on price. This means that our new requirements coming, and we need to jump to another option of integration. And Django Filter supports that too. You just write your own price filter. And look that I only changed the Django Filters code. I didn't change the code around it. And this is really good because Django Filter supports multiple options of integration, and it's really smooth to change between those options. If we didn't have multiple levels of abstractions in Django Filters, if we didn't have the multiple options, we have a discontinuity. We had to jump from a simple integration to a very complex one. And this would be really difficult for us as app users, as API users. So to increase granularity, we must have multiple levels of abstraction, and this is good. This is not bad to have an API with multiple levels of abstractions. Alex Martelli talks about that on Good API Design Talk. But what about the Zen of Python? It says that there should be only one obvious way to do. Yes, but an obvious way to do. Obvious is the 80%. You should have only one 80% use cases way to do. But you should have many options of integration, many lower level abstractions for the other 20% that want extensibility, that want to dive into your API. So obvious way for the 80%, non-obvious way for the 20%, but give those non-obvious way too with flexibility and low-level interfaces. And also to increase granularity, we need to ensure the extensibility of Django idioms. We just can't use them right away. We need to make sure we are making them really granular. Going back to the examples we saw before, if we are using template tags, like this one, avatar URL template tags, maybe we should separate the code that handles the tag, that puts something on the template, for the code that calculates this, that gets this logic. And Django Avatar does that. It supports custom backends. So it comes built in with backends for Facebook, for, I don't know, for GitHub or something. But you can write your own provider and you just add them to settings, and this library can connect with your own avatar providers. And this is good because you broke the logic, you encapsulated and broke the logic of custom avatars via helpers, providers, backends. Each library calls it one way, but they are all the same thing. The logic is encapsulated and separated and can be configured via settings. This is good and really important. You just can't use right away tags. You must also make those tags customizable. Class-based views too, you should break the behaviors into attributes and methods. You must not have a custom gigantic method that if anyone wants to change the behavior, needs to override it all. If you have something that is frequently changed by your app users, maybe it should be an attribute or a custom method. And back to Django Out Tools, password reset view. Obviously, your users will want to change the template or will want to change the from email from the password reset. And this library already provides that as attributes, and this is good. Also, custom query sets, this is already for free if you use custom query sets, but they can be intertwined with custom logic, like search for future event pages in Wagtail. You just put your own logic, and after it, you call the search method provided by Wagtail, and it just works. So if you use custom query sets, you have this ability instead of using managers where you don't have this ability to intertwine your custom logic. Another thing for flexibility is to increase the opportunities for extension. You should look for the mock patch smell, because every mock patch is a missed option of integration. If you are writing tests and you are having to patch things like this, this means that you have one less option of integration. So for example, a test that sends email, you have some logic, and then you check if the send email mock was called. Okay, this looks good, but this is a missed option of integration. Why not having the email backend as a setting, and setting this on the test settings, and then you just get this email backend and check if the email was sent? Django does that because Django has custom backends. And maybe if you are mocking patching a lot of things in your app, maybe this thing should be customizable in a setting or something, or like accepting a custom argument, accepting a parameter for it. This is a smell that you must check for. And also the attribute versus method smell, because every attribute that could be a method is a missing option of integration. A practical example in REST framework, previously the custom pagination in REST framework didn't support custom page sizes because the page size was an attribute instead of a method. So you couldn't change the page size according to the request for cursor pagination. And this is useful, even though it's cursor pagination, you may want like to change the page size if the user is a premium user, or if the user is a regular user, you may want to give a large page size for the premium one, don't know. So you must get the request for that instead of having a fixed page size for everyone. And they fixed that adding a hook, get page size, instead of having page size as a fixed attribute. Okay, now about safety. Safety here, you probably can't see, but it's Freddy Krueger here. And you must think that your Django app user is a serial killer, because you don't want to do dangerous things by default. For example, on serializers, if you don't specify fields, what should happen? Should you show all fields of the user, or should you show nothing? Previously, both Django and DRF showed everything. So if you wrote a serializer and you, for some reason, forgot to set the fields, you'd show your user's hashed password for the API. And it's probably not what you want, because it's not the safest behavior. So eventually, both change it to the safer behavior. So you must think about that. Don't do dangerous things on default. And this is really important, because this was a reason for a real bug that happened because Rails had a setting that by default was very unsafe, and GitHub had this active on their code base, and this led to an exploit. Another idea for safety is to prevent common mistakes. I bet that many of you have been saved by that. Google prevented you from making a mistake because it knows that probably you are making a mistake if you wrote attached on your email and you forgot to attach something. And this is great. This means that the user interface is preventing you from making mistakes, and you can make that on Django apps too. Many people don't know that, but you can bundle your app with Django system checks. And what are those? You can put those on checks.py, and if people run Python manage PyCheck, they will run constant checks that you wrote on their code base. So for example, here an example of a check. There's a subtle bug here. You are using the same namespace for 2 different apps, and if you run manage.py check, the system check framework will detect that for you. And this is a check that comes built in with Django, but you can write your own to prevent common mistakes that users make on your app. And here's an example of a thing that should be checked, but it isn't. On Django, you have array field for Postgres. And on the documentation, it says that if you give the field a default, ensure it's a callable. Because if you use like default and pass an empty list, not a callable, this creates a multiple default that will be shared between all instances of array field. And this is a bad thing. You probably don't want that. So maybe a suggestion for Django, everything that's on docs that says ensure, remember to, don't forget, or similar warnings should become a new system check. And if you are writing the documentation for your app and you are writing, be careful, warning about this, maybe this should be on the documentation and also as a custom system check that you write to prevent the users from making a mistake. And if you can't prevent it, fail fast. Raise exceptions as soon as possible if the developer makes some mistake. And good apps do this. Django filter does that. It raises improperly configured if you forget to set filter set class. And Django REST Framework now raises type error if you forget to set fields on a model serializer. Like we saw before, if you put fields empty, in previous versions it showed all fields, but now it shows type error if you forget to set the fields of a model serializer. And this is good because it's failing fast instead of getting into an unexpected, unsafe behavior. And many of those things are listed on Django Apps checklist. It's a checklist that I wrote, and some people already contributed with it, and it is really important for the community to write this in an easy way to be consumed. And you can go there and check, and then come back again, and the checks will be saved. And you can do that for your own apps. You can add new checks there. It's open source. Feel free to contribute. Okay, so that's it. Feel free to reach me. Slides are available on this link. References, if you don't want the slides, you can click there. There are much more content. There are the other talks I talked before, like the one for Alex Martelli. Interesting stuff on these slides, so feel free if you have any question. Thank you. Sorry, I missed.
What's a practical difference between the Django check system and like linter?
Yeah, so I'll talk about that tomorrow. I'll talk about linters tomorrow because another speaker couldn't come, and I'll replace him. And the thing is that linters, most of them do static analysis. So they check your code without running it. And the system check framework is like more on the dynamic analysis side, because in kinds of runs your code, it kinds of like load your models, and you can do more complex checks there instead of like using PyLint or something. So it's very Django specific, because you have, if you use Django System Check Framework, you can load your apps, you can inspect stuff that it would be very difficult to do on just a static analysis standpoint. Anyone else? Okay, so thank you very much. Feel free to reach me on Twitter.
Thank you, Flavio.